This video is about transformations and congruency. As you watch the video, I want you to fill out the transformation notes page. As I move along, I'm not going to pause the video to give you time to take notes. If you need extra time, you're just going to have to pause the video on yourself so you can have that extra time. All right, first of all, let's just talk about what a rigid transformation is. A rigid transformation has the same size and shape after the transformation. So the location might have changed where it is on the coordinate grid, but the size and the shape are the same. The original figure, the pre-image, is going to be the same as the image. And you'll want to fill in on your paper, after a rigid transformation, you have a congruent figure. And there are three different types of rigid transformations. We have a translation, which is a slide, a reflection, which is a flip, and a rotation, which is a turn. Let's talk about slides first. A slide is where you just move it somewhere else. So you might slide it upwards, you might slide it downwards, you might slide it left, you might slide it right, you might slide it diagonally. What you'll notice about this picture is that you have two shapes, and the original and the new are congruent. They're the same size, they're the same shape. The only difference you'll notice is that they're in a different place, and as you can see, they have different labels. This little apostrophe we call prime. So we would call this figure the pre-image, and we would call it A, B, C, D, E. And then we would call this figure A, B, C, D, E prime. So we have our original, and then we produced our new. Again, a translation is a slide. Here's another example, and it's on a coordinate grid. And we would say that this translation was 6 units to the right. So if you take a look at each individual piece, you'll be able to see that, for example, C moved 1, 2, 3, 4, 5, 6 to the right. B also moved 1, 2, 3, 4, 5, 6 to the right. And the same with A, that distance is 6 units. Here's another example of a slide, and it looks like this one moved diagonally. Another way to think of it is just in two parts, the horizontal movement and the vertical movement. That's how we're going to talk about it in this class and what you'll see on the EOG. In this example, I'm going to figure out which one is the pre-image and which is the image, and we'll label it. So there's the pre-image, and here's the image, and the way you recognize it is by noticing that each of these labels have an apostrophe attached. So this is A, B, C, D prime, it's the image, and then this is the original, the pre-image. So what happened is we took each point, let's try A, and we moved 1, 2, 3, 4, 5, 6, 7 to the left, and then we went downwards 1, 2, 3. So 7 to the left and 3 units downwards. You do the same thing with every single point. So let's look at point D. 1, 2, 3, 4, 5, 6, 7 to the left, and then 1, 2, 3 downwards, and you form D prime. On the EOG, the most common mistake I see is that students do not properly recognize which is the pre-image and which is the image to talk about how the original was translated to create the prime figure, the new figure. Another example of a translation, and in this one we're going to figure out how it was translated. First we're going to label our pre-image and our image. So this is prime or new, and this one is the original. To figure out the translation, we're just going to take one of the points, for example B, and we're going to see how the figure was translated so that we get to B prime. So I move it 1, 2, 3, 4 units to the right. And then we move downwards 1, 2, 3, 4, 5, 6 times. So 4 to the right and then 6 downwards. Let's look at C. Again, we go 1, 2, 3, 4 to the right. And then we go downwards 1, 2, 3, 4, 5, 6. So for each point, you'll notice it's the same. 4 to the right and 6 downwards. Let's write that rule. So this was translated 4 units to the right and 6 units downwards. You want to fill this in on your notes page. So we have the before and the after, the pre-image and the image, the original and the new. And then this is just how you talk about it. You would say figure A, you pronounce it figure A, and then you could pronounce the new figure, figure A prime. And then points A, B, and C, and then afterwards you have points A, B, and C prime, and prime means new. Now we're moving on from translations to reflections. A reflection is also known as a flip. So I just have a series of pictures to show you reflections. Here's another reflection. So they're all being reflected over this line of symmetry. Once again, we have our line of symmetry. The line of symmetry is also called the mirror line. If you look at this example, you have the mirror image of N. I don't know if you guys have ever written out a message backwards and given it to a friend and then asked them to put it in front of the mirror, so it's sort of, you kind of coded it in a way. It's sort of an elementary way to code something, but I always thought that was a cool idea, because normally if you hold up something that's written, you know, properly in the right direction, hold it up to a mirror, it looks funny, it gets flipped. One more example, we have R being reflected. So we have before the reflection, after the reflection. And then some more notes for you guys. So the line of reflection is the line the figure is flipped over. It's also called a mirror line. This year you will only be asked to use the x-axis and y-axis as the line of reflection. In the future, you might be given a random line. For example, maybe y equals x. And you might take a figure and actually flip it over a different line of reflection. But this year, remember, we're only using the x-axis or the y-axis as our line of reflection. Our first example is where they're flipping it over the x-axis. So if you look at the pre-image, you can see that it's been flipped over, and I'll highlight it, the x-axis, to create the image. And we know this one is the image because of, you know, where it says C prime, B prime, and A prime. When you think about actually being asked to do this on your own, if I had this pre-image here and I was asked to reflect it over the x-axis, what I would do is I would count the distance from a point to the line of reflection. So for example, C is a distance of 2 away from the line of reflection, the x-axis, and then I would count in the other direction, 1, 2, and then I would mark C prime. So if C is 2 above the x-axis, C prime is going to be 2 below the x-axis. Let me give you another example. Let's say we look at A. A is 1 unit above the x-axis, so A prime is going to be 1 unit below the x-axis. And the same with B, we go up 1, 2, 3, 4 upwards. So I go the opposite direction, 1, 2, 3, 4, and we form B prime. So that is how you would reflect it over the x-axis. Our next example is a flip over the y-axis. So we're flipping it over a different axis, a different line of reflection. And the concept is the same. You would look at the distance to the left, where you find the point on the pre-image, and then you're going to move that same distance to the right to form the point that will make the image. And now we're on to rotations. I always like to ask when we look at this picture, how many items or things are rotating in this picture. So take a second, think about it. And here's just some suggestions. It really depends on what you're going to count as rotating, if it's a separate piece or not. But I always count the 4 wheels on the shopping cart. Of course, you have the wheel on the back of the bicycle. Some students have said in the past, well, the guy's feet are actually rotating. You could say the pedals are rotating. You could say the gears here are rotating. And you might have even been able to come up with some more things that were rotating. Here's another funny example where they're pedaling. It's super high in the air. I don't think I would ever want to get on that bike. It's so high in the air. But again, the idea is that these are rotating. It's a rotation. All right, rotations again. We're going to talk about specifically how something rotates, or the degree by which it rotates. In this example, we could say that the seahorse rotates 90 degrees clockwise, or to the right. Or we could say that the seahorse rotates 1, 2, 3 times and to the left. So it would be 3 turns would be 270 degrees. Well, 3 90-degree turns would be 270 degrees counterclockwise. So here are your notes on rotations. First of all, the center of rotation is the point around which a figure turns. This year, they're limiting our center of rotations. The only one we're going to use is the origin, 0, 0. That's going to be our center of rotation. We're going to look at clockwise rotation, and we're going to look at counterclockwise rotation. So if you think about a clock, if you move forwards, 1, 2, 3, 4, 5, you follow the natural pattern of the clock. That is considered clockwise. So you'll see that we are really going to the right. So clockwise is when you're rotating to the right. And then counterclockwise, if you're going backwards, 12, 11, 10, you're going against the clock. Counterclockwise, you're going the opposite direction. So you're actually going to the left. So to the left is counterclockwise, to the right is clockwise. And we are only going to look at 90 degree, 180 degree, 270 degree, and 360 degree rotations. If you think about it, they're all multiples of 90 degrees. So we have 90 plus another 90 gives you 180, plus another 90 gets you to 270, plus another 90 gets you to 360 degrees.